we've got Shai coming over. He is an iOS tech lead from Get, an on-demand mobility company. He's a core contributor to RX Swift and works as an author and editor at Ray Wenderlich. He's actually one of the authors of the upcoming book on Combine, which actually has the cover with this adorable polar bear. That idea is completely thanks to his wife. He came all the way from Israel, so give a warm welcome for Shai.
Thank you. Thank you so much. Good afternoon. So I hope you're all full and happy from lunch and awake also. So we have a lot to go through today. I want to teach you just enough about Combine so you're motivated to go home and mess with it and hopefully enjoy and understand why it's such a powerful technology that we got from Apple in this year's WWDC. So let's get started with the basics. What is Combine? I always like to start with the textbook definition of this. So Combine is a framework that provides a declarative Swift API for processing values over time. And these values can represent many kinds of asynchronous events and work. But I really want to focus on the word asynchronous here. What is asynchronous? When you come to think about it, basically everything in your app is asynchronous. Everything that you do in your app happens over time. Whether it's networking, UI events, notification center, it's things that happen over time, constantly. And Combine all of these things can be represented by something called a publisher, which you'll learn in a bit. So consumers can subscribe to these publishers to be notified whenever there are new values emitted from them and constantly update their app so it's constantly up to date based on the latest state of the app. So if you have a publisher that says, hey, I perform some work and I emit values and that they change over time, have a subscriber that says, cool, I'd like to receive these values so I can keep my app up to date. And they constantly communicate between themselves. Our purpose is really to sort of publisher all the things, because the more you have publishers, the more you can put them together and make really interesting compositional ideas and options. So if you think about it, today, we have a lot of different ways to represent asynchronous work. We have taps on a button that are IB action, or a network request where we would use closure to handle our result. And that requires quite a bit of juggling between different contexts, how we take these different results and put them together. As opposed to it, Combine takes all of these things and puts them under the same type of interface. All of them are a publisher. So once you have everything under the same interface, composition is very, very easy and very powerful. And you get a unification of how you deal with work across your app. Also, now the big two words, reactive and declarative, the fancy buzzword. So when you subscribe to a piece of work, a piece of information, you always get the latest value from it so you can update your app. So let's look at an example to really illustrate it. We have a user that has some money. They have $5 and they want to purchase a $10 product. Can they make that purchase right now? The answer is false. They don't have enough money. Later on, they go to an ATM. They get $20 more, and now they have $25. Can they make that purchase? That would still say false. And that's because can make purchase does not reflect the latest state of your system. It reflects a specific snapshot, a static snapshot in time of when these values were 5 and 10. As opposed to this combined code, which you don't necessarily have to understand, but it's pretty straightforward, you always get, can make purchase will always reflect the latest state of your system. Whenever either product price or the user balance changes, you're going to get a remap of this and get a new Boolean emitted. So you can constantly make sure that can make purchase is valid if you have a button feeding off of that value. Okay, so now we're going to dive a bit into some combined theory. I think it's super important to understand how the different pieces work and what they are so you can choose the right tools for every piece of your work. So first of all, there's publisher, which we started talking about. So it is a type that can emit a sequence of values over time. It has two generic constraints, the output, which says which kinds of values it can emit, and a failure type, which says which kind of error it can fail with. It can emit three types of events, a value event, which is again of the generic output type that we defined earlier, as well as either of these two finishing events, either a regular finishing event that says everything finished successfully with no issues, or a failure event that says it completed but something went wrong. Publishers may emit endlessly as many values as they have. They can just emit as many values as they have until there is some completion event. Once an error occurs, or once a regular completion value event occurs, there will never be more values emitted from that publisher, which is a really strong guarantee that you should be aware of. The next piece is called a subscriber. So if a publisher is this sort of a push-based interface, it delivers its values to subscribers. And subscriber has this same generic constraint. It's just called input. That means what kind of values can I accept as a subscriber, and the failure, which again, what kind of failure can I accept as a subscriber. And as you can imagine, the output and input of the publisher and the subscriber must match, as well as the failure. So the subscriber can only subscribe to a publisher that has the same output as its own input type. So now the only thing we need is that between the publisher and the subscriber, there is this missing piece that lets them communicate between each other. And that piece is called a subscription. So a subscription really represents the heavy portion of the work, the connection between the subscriber and the publisher. And it's really where most of the heavy work happens and where events are actually delivered to different subscribers. So the publisher initially creates and provides a subscriber using the subscriber's receive subscription method. It creates it and then just pushes it to it. And from that point on, it can send values to these subscribers with two methods. Either the receive input method, which lets you send values to these subscribers, or receive completion, which lets you send either of the two completion events we mentioned earlier. A subscription represents a resource. So once you're done with it, you can call its cancel method to cancel it, or you can simply deallocate it. Once it's deallocated, it's entirely released, and all of the memory allocated to that resource and to the attached subscriber is also released at the same time. A subscription has one final really crucial role in Combine that's really unique in the reactive programming world of Swift, at least, and it's called backpressure. I'm going to really shortly touch on that. So that's a really fancy term. It basically revolves around strategies of how you deal with publishers that emit way too many values very, very fast in a way that the subscribers that doesn't have enough time to deal with them. For example, if I have a publisher that emits 10,000 values over a single second, and a very confused subscriber that doesn't know how he's supposed to actually process all these values so quickly. So what Combine does here very cleverly is that it transitions the control to the subscriber. The subscriber says, I would like to receive up to some amount of values. And until that demand request happens, the publisher will not produce any values. Once that happens, the publisher says, here are some values. I will never give you more than you demand. It must always respect that contract. And finally, the subscriber can constantly adjust its demand. So if I just got 2 values, I can say, I would like to accept 3 more values now. I'm willing to process them. I now have the capacity to do that. And there are a couple of types of demand. The first one is unlimited, which is the default, meaning give me as many values as you have. I can deal with it. It's not a problem. Second one is none. I can't deal with any values right now. And the final one is up to a certain maximum, like an integer, 3 values, 5 values, or whatever. And all publishers in Combine must respect this contract. If you have your own custom publishers, they have to respect this contract and only produce values up to that subscriber's demand. Or based on Apple, it's considered an illegal publisher, and there could be some unexpected behaviors in the subscription tree. Moving on to one less theoretical sort of piece here called a subject. So a subject is a really interesting kind of publisher that you can manually send values to. So up until now, we talked about a publisher, and this one is immutable, and the values are computed internally. You subscribe to it, and you get some values that it produces. For a subject, you can actually send values to it directly, so it's mutable. So it's really useful for reading some imperative code you have. You can just send values to it. Let's look at some examples of that. So in Combine, we have 2 kinds of subjects provided for us. The first one is called a pass-through subject, which is really useful for representing events, things that happened. For example, a tap event. I can have a tapped button pass-through subject whose output is a void and never errors out, and I can just send an event to it, sending a tap to the subject. And existing subscribers will be notified that this tap happened and can react to that and update the app accordingly. New subscribers get any values after the subscription. And this is an important distinction. It means that if an event just occurred and you subscribe after, you're not going to know it happened. You only know what happens in the future, but not in the past. That's why it's event-based. As opposed to it, we have a current value subject, which is really useful for representing state. It takes an initial value. Is loading is a great example of something stateful. So it takes this initial false value. You can send the value to it just like a pass-through subject, or you can even set it directly using the value setter on it. And here, when you subscribe, you always get a replay of the current value. Again, because it's stateful, it's imperative that you get the current value of it once you subscribe to isLoading, for example. Let's do a quick recap, because that's a lot of information. So first, we have our app with the subscriber, and the subscriber and the publisher are connected. They're attached using the publisher's subscribe method. Later on, the subscriber is provided to the publisher. The publisher creates a subscription and sends it to the subscriber. At this point, the subscriber and subscription talk to each other, and the publisher is sort of out of the point. The subscriber says, hey, give me up to some amount of values. Subscription says, here are some values, and the subscriber can constantly adjust their demand based on these values if they want more values. And finally, you're going to get some completion event at some point to indicate that there are no more values coming from that subscription. Wow, that was a lot, I know. We only have 25 minutes, so I'm trying to push as much as you can. But don't worry, this stuff you're going to meet it in different scenarios, and it's going to make more sense as you experiment with it. But the best way to just get it into your system is start experimenting with some more practical examples. So let's talk about some combining practice. So we have all of these publishers. Great. What do we actually do with them? How do we get values off of them to use them? So there are two built-in ways to consume publishers in Combine: sync and assign. Sync is a closure-based subscriber. You just provide it two closures, one for values and one for completion event, and then you can do whatever you want with these events as they come. You can update your UI, you can print it out, you can do whatever as you subscribe to it. In this case, I'm just printing, hey, there, try, Swift, and eventually a regular completion event because there was no error. The second kind we have is called assign, and assign is really cool because it sort of creates a binding between publishers to any key path you want. It could be a UI element or any object. So I can take this publisher and I can assign it to the text key path of the text field, a UI text field on my app. And then whenever the publisher emits through this assign, it's going to constantly update my UI text field whenever that value changes. So if I have a publisher that emits a value every 5 seconds, it's going to change the text field to always have the latest value displayed on your text field. So it's really like a binding mechanism. So OK, now I have these values, and I have ways to get them, which is really useful. But sometimes the values you get from publishers aren't the values you actually want to use. You want to manipulate them. You want to change the values so you can do different things with them. And in Combine, you use something called operators to do just that. So operators let you manipulate values and events coming from upstream publishers and control the emissions in really expressive and interesting ways. If you have a publisher that goes through some operator, you get a new modified publisher that is affected by that operator. And really, if you think about Combine as a language like the English language, operators are really the words. And the more words you know, the more complex sentences you can compose, and the more interesting logic you can build inside Combine. So they are really simple chainable method, and many of them have names that are similar to ones in the Swift standard library. Let's take a quick look here. It seems like a lot of code, but we already can spot a few names that we know. Compact map, map, filter, append. These are all names that we know from the Swift standard library. But don't worry, we'll go through each of them separately so you know exactly how this piece of code works. But first of all, this last operator, append, only starts working when the publisher completes. So we're going to gray this out for now, so you're not going to deal with it. So starting with the first one, we have a compact map trying to cast this string into a float. That's not a problem. It can be cast to a float. Then we check if it is a duplicate of the previous value. It's not. We seal it up to 2. Is it smaller than 4? No. And then we hit this drop first operator. And that, what it does, it just drops the first element that is emitted. In this case, it's this one. So it's going to just drop it. But then it's never going to do its work again. It only works on the first value and then stops. Then we get a second value. Can it be a float? Yes, it can. Is it a duplicate? No, it's not. We seal it up to the same value. Is it smaller than 4? Yes. So it goes to our output. Finally, again, we have 2. Is it a duplicate of the previous value? Yes, it is. This is really, really powerful ability that you get for free using this operator, having the ability to detect duplicate values inside a stream of values that happens over time. So you get it for free by this simple keyword in a way. Then we have try and swift. These are both strings, and they can't be cast into a float. So they both are nil, and they are filtered by the compact map operator. And finally, we have 0.2 that can be cast to a float. It is not a duplicate of 2. It can be rounded up to 1, and it is smaller than 4. So it goes to our output. Finally, like I said, we just got to the completion event. So this append is going to start kicking in. Append takes any kind of sequence, basically. It can take an array, it can take a different publisher, or it can take a stridable, like it does here. So you can just generate elements inside that stridable. So you make all these 3 elements, put them in the output, and only then push that finishing event down the stream. One interesting fact about operators is that they are themselves publishers, and they have their own types, and each type wraps the type of the previous one, which might be a bit confusing. So here we have our any publisher that emits strings. It's wrapped by this compact map. Then it's wrapped by remove duplicates. Then it's mapped by map. Then it's mapped by filter. Then it's wrapped by drop. And eventually, by the end of the chain, this is the return type, this thing. So if you have a method that does this computation and you want to return this, you have to return this entire thing to your consumers. And this is really problematic. First of all, it's a huge headache, right? I don't even know what's going on here. And the second thing is I'm exposing my implementation details. I'm exposing what are the operators I use for my publisher. So there's a better way around this. There's an operator for type erasure inside Combine called erase to any publisher. Once we use it, we just get any publisher of the final type of both the output and the failure, which is really useful. We are hiding our implementation details, and we provide the output to the subscriber. Another very useful operator you should know is the print operator. Like the name might hint, it just prints out whatever goes through it. So here I have 2 print operators, publisher and uppercase, and I can see exactly what's happening. I can see there's a subscription to the first one, and then for the second one. Then I see there's a request for unlimited. This is the demand of the backpressure we discussed earlier, unlimited demand in this case. Then we get the first value, then the uppercase value, then the second value, then the uppercase value, and eventually both of them finish. And this is a really useful way to debug once things aren't behaving as you expect them to inside Combine code. Sometimes your publishers won't fire events, won't fire values, and you wouldn't be sure why. This is the perfect way to check what's wrong. Okay, so finally, a great thing about operators is that they work on any kind of work. Because publisher is a single interface, I can use map and retry on a network request, which is standard, but I can also take a video decoding session and wrap it inside the publisher. And now these map and retry, that exact same language works on any kind of work I have in my system, which is super, super powerful. From here, I want to move on to how Combine lives inside Foundation APIs, a very interesting topic as well. So Foundation provides some really useful publisher abstractions for the things you do in your daily life. First of all is sequence.publisher. You saw it already used a couple of times. Basically, if you do .publisher on any kind of sequence, you will get a publisher that emits the values of that sequence. Here's an array, a range, a stridable, and it even works on a dictionary, in which case it emits key value pairs of the dictionary. Notification center, as I mentioned earlier, notification center is also asynchronous work. I can have a publisher for my UI responder keyboard did show notification, and then I would get an emission. Every time the keyboard would go up, I can get the frame of the keyboard going up, and I can use operators on it and compose it with other publishers, so it's really, really powerful and strong. Okay, a quick intermission. So lately I became father to 7-week-old baby Ethan, and he's the cutest thing. Thank you. And we always have the best talks. I know he's only 7 weeks old, but we have the best talks. He always tells me, hey, Dad, do you mind telling me a joke? And I'm like, yeah, sure. But he's very elitist and very picky about the technology he uses. So he says, like, you have to use Combine or I'll start crying. So I'm like, OK, sure. We have the tools to do that. It's not a problem. So like we have a data task on URL session, we have a data task publisher. Because I still don't know too many dad jokes, I'm just going to use the ICANN dad joke API. Like I use a regular data task, I just use data task publisher, pass in our URL request, and like I would get a closure of data and URL response, we're getting a publisher of data and URL response. And I can use a sync like any other publisher, and then I get back my joke. Can a kangaroo jump higher than the Empire State Building? Of course, the Empire State Building can jump. I can even use, thank you. It's the API's joke. I can't take any credit for it. Another very useful operator here is decode that you can see here. Decode works on any publisher of data type. And all it does is use whatever decoder you pass, either a JSON decoder or a PLIS decoder, whatever you use, and decode it to some object, and in which case you would get the object inside this sink, an actual joke struct. And this is really useful because you don't have to map manually or break the chain. You get an actual operator that lets you really fluently create this composition. Also, you can have any KVO-compliant key paths observed as well as a publisher. For example, the content offset of a scroll view, the status of an AV player, or even the queue priority of an operation queue. One final treat master as a property wrapper we have published at published. That makes any property you want a publisher itself. You can use it just like a regular imperative property variable, but once you use the dollar syntax, it becomes a publisher. And you can subscribe to it just like any other publisher you have. And you can even mutate it directly like you would any other property, and it would emit to any existing subscriber. So it's really, really useful and powerful. Now that we have all of this foundation stuff out of the way, I really quickly want to touch on how Combine and Swift UI live together. It was a great talk from Leah earlier today, and it's really going to touch about some of the same things. So they are really deeply integrated together, and SwiftUI uses a lot of combined features under the hood to reactively update all of its views and know when to redraw them. So for example, observable object, which you learned about earlier today. If you look in the implementation, you will see that the observer object will change publisher is a publisher. It's a combined publisher under the hood. And if you look at observed object, it uses observable object under the hood, which is also using a publisher. Same thing for environment object, using observable object under the hood. All of these things are using combine under the hood to drive SwiftUI view update. And also, every view in SwiftUI has the onReceive that accepts, you guessed it, a publisher. So this is a really short taste of the fact that SwiftUI and Combine are super, super deeply integrated together, which is just another reason that you should understand at least basically how these things work, because you're all going to be writing a lot of SwiftUI code very soon, I hope. I want to spend a few moments to talk about community. So Combine is new, but reactive programming is not. There is a really thriving and large community of reactive development, mainly RxSwift and Reactive Swift, that kind of paved the way. And if you are developing in any of these frameworks, your knowledge is transferable to Combine. It uses many of the same techniques, many of the same concepts. You just have some different names, basically. And there are a few key differences that you should be aware of. First of all, Combine uses iOS 13+, which might be an issue for some people that want to go to production. They have to wait maybe 2 years if they want to support the 2 previous operating systems. Reactive Swift and RxSwift use iOS 8+. We also still don't have Linux support on Combine, which might change in the future. Combine is maintained by Apple, which it might be actually an upside. We have people that get paid to constantly maintain that framework and not open source maintainers, which is a very different concept. And final 2 things here, typed errors. We have typed errors in both Reactive Swift and Combine, but we don't have them in RxSwift. And for backpressure, as I mentioned earlier, only Combine does backpressure in Swift, even though RxJava does it, for example. But in both RxSwift and Reactive Swift, we don't have backpressure. I also want to share a few interesting open source Combine projects, because there's already a big community around it when you compare it to a really new project. The first 2 ones are my own. Sorry for the shameless plug. The first one is Combine Cocoa. If you know RxCocoa, this is very similar. It provides publishers for common UI kit elements, so you can subscribe to the taps of a button, the text of a text field, etc. And the second one is RxCombine. If you have an RxSwift publisher, observable, sorry, you can migrate it to a publisher very easily using these bridges. Also, there's Combined Data Sources by Marin Todorov, who gives very interesting abilities to bind a publisher to a table view or a collection view to constantly keep them up to date. There's also Combined Feedback based on Rx feedback and reactive feedback that provides a very interesting take on unidirectional data flow with Combine. The two final ones are Entwine, interesting testing tools and utilities for Combine, like a test scheduler, and Harvest, which offers an interesting Redux realm-inspired state machine in Combine, also very much worth checking out. If you want to learn more, a couple of good resources I want to share with you. First of all, there's Try Combine by Marin Todorov, a very nice blog, really recommend it. There's also Combine 101 by Scott Gardner that has a GitHub page with really much of the things that I taught you here just laid out in textual form and a bit easier to follow for some people. Antoine Vanderlee has Swiftly. He has a whole category about Combine that you should read, very interesting posts. And Cocoa with Love by Matt Gallagher. This is one of my favorites because he kind of tackles Combine from very interesting angles that people usually don't necessarily try. I'm going to send you all these links later. No worries. You're going to get them with the slides. And finally, if you want a more guided learning path, we're actually making a book, like mentioned, Bear Cub here. And it's currently in early access, and the full release is coming very, very soon. You can get it at bit.ly/getCombineBook. And we're also going to be raffling a couple of them, I think, tomorrow. We're going to share more details a bit later. And I want to teach you so much more, but this is all the time I have. So thank you so much.